This is a continuation of quality control lecture. To recap, constructing the X-bar and the R charts, K is going to equal the number of samples, and N is the sample size. So you're going to need to collect 25 to 30 samples and 3 to 10 observations each. The overall mean calculation is the grand mean, or the X double bar is the average of all of the averaged means. The average range, the R bar, is calculated as all of the ranges averaged together. There's the formula for both. The average range and average mean are used to compute the upper and lower control limits, UCL and LCL, for the charts. And these numbers are going to be the D4, D3, and A2 are actually taken off of a chart, which is found later on, the factors for control charts. So those variables are going to be, or values are going to be taken off of this chart, and it's going to be based on the number or the observation. So when there's 3 observations in our Goodman-Tyer example, 3 observations, the X bar, you're going to look across for these values. And the R chart, again here. But we'll cover this a little bit further on, give an example of it. So as stated, the D3, D4, and A2 are all constants that depend on the sample size N. Characteristics of a control chart for a process that is under control. You'll find that no points are outside the control limits, so the upper and lower control limits. No points, the number of points above and below the center line is about the same. They also fall randomly above and below that center line. And most points are near that center line, which is again our target value, and only a few are close to the control limits. Some rules for identifying a shift in a process that may indicate that a process is going out of control. We want to actually have specific numbers that we're using, not just a random look at the chart and say, yeah, that looks like it might be starting to go out of control. We actually have some rules that you can use, not something that you have to memorize, just be aware of. That 8 points in a row are above or below the center line. So we're using an example here. Our center line, our upper control limit, and the lower control limit are the darker lines there. So when you're looking at your points or your values, when 8 are below or above in a row, you're going to find that something is out of control. If 10 of 11 consecutive points are above or below the line, if 12 of 14 are above or below that center line, if 2 of 3 consecutive points are in the outer 1/3 region between the center line and one of the control limits. So here we took the upper and lower control limits and our center line here. Excuse me. This area is just broken into thirds for looking at convenience sake. So in order to determine if something is out of control. So here's a third, another third, a third. So when you see 2 of 3 consecutive points are in the outer 1/3 region between the center and, so we're looking at 1/3 region here, 2 to 3 are in the outer 1/3. So 2 of these 3. So you're going to say this is out of control. Also, if 4 of 5 consecutive points are in the outer 2/3, so the outer 2, here's the 1/3, outer 2/3, if 4 of 5, 1, 2, 3, 4, 5, so we've got more than 5 points here that are getting to be out of control. 1, 2, 3, 4, 5, 6. So of the 5, we've got 4 that are out of control. Likewise, in the lower 2/3, 1, 2, 3, 4, 5, 4 of these are in the outer 2/3. So again, out of control. You're seeing an out of control process or conditions that are existing here. So it would be good to, if this is in the production line, to go back to those time periods where those samples are taken from in order to see if something needs to be addressed. Well, actually, something does need to be addressed because these are out of control. So those are general rules for identifying when something is going out of control. In summary, the statistics needed to build the R chart and X bar chart. For the R chart, you need to have R where the range is equal to the range of each sample. The R bar is the average range of all samples. D3 and D4 are constants based on the sample size. Our upper control limit for the R chart and lower control limit equations are found here, where X double bar is the grand mean, and X chart, where R bar is the average range of all samples, X bar is the average of samples, average of observations for each sample. The X double bar is the average of all averages. So it's also considered the grand mean or the overall mean. A2 is going to be based on that chart, based on the sample size. And again, our formulas for the upper and the lower control limits. So to actually put this into practice, we're going to look at an example. Looking again at the Goodyear tire example and just looking at the first 5 data points. There are 5 samples, and for each sample there are 3 observations. So the first step is to calculate the average of each sample and the grand mean. So the average for each sample, again, is 31, 42, and 28 divided by 3 gives us 33.67. Sample 2, 26, 18, and 35 divided by 3 gives us 26.3, and so on for the last 3 gives us our values. Then we take those averages, 33.67, 26, 33, 29.67, 21, and 34, and divide it by 5 to get our average for our grand mean, X double bar. Next, we need to calculate the range of each sample and the R bar average range. So first off, you start off with the range, which is your maximum minus your minimum value for each sample. So in the first one, you're looking at 42 minus 28 gives us 14. Our next one is 35 minus 18 gives us 17. 34 minus 25 gives us 9. And the last 2 is 8 and 9. Once we have our ranges, we add them all up to get our, divide by 5 to get our average range of 11.42. Next, we go to our R chart. So our upper control limit and our lower control limit, first off, our upper control is D4 times R bar. So D4 is the constant at our n value of 3. So if we go, we're looking at the R chart and D4. So R chart, this last area, D4, and then we're looking at where n is 3, go all the way across, and it's 2.574. So 2.574. Then we're going to do this for the D3 as well. The D3 value for 3 is 0. So I put that in there. So our upper control limit is D4, so 2.574 times our R bar, and our R bar was 11.4, which we calculated up here. multiply that together to get 29.34. Our lower control limit is D3, which we found a value of 0, times R bar, again, 11.4. 0 times 11.4 is 0. And then by hand, we're graphing this. You start off with your samples are 5. You're plotting the R of each sample. So your R bar, your R or your range for the first one is 14, second one is 17. And we come back with our lower control limit was set to 0, and our upper control limit was 29.34. Our center R bar was 11.4. So the average 11.4 for the range. And that shows us that right now with 5 points, it looks like our process is in control. And I don't know if you want to look back, but if you look back at the actual example, let's look at, say, our grand mean is 28.93, and our Goodman example for all 30 our grand mean was 31.88. So what makes the difference between the two? And that's simply because we are averaging only 5 data points versus 30. So you'll find that our results might be a little bit different than what the Goodyear template chart in Excel showed. So we do the same with the X bar chart. We have an A2 constant that we need to pull from the chart for the X chart. Our N is equal to 3, and we're looking at A2 is 1.023. So we put 1.023, and we just, R bar, we calculated, is 11.4. So we pull in these values, plug them in, and do the math. The upper control is an addition, while the lower is a subtraction. And we get 40.59 and 17.27. Hand sketching this, we got our chart here, 5 data points. This is going to be plotting the mean of each sample. So we start off with our center line, our target value, which is the grand mean. For grand mean is 28.93, so we can put that in there. Then our upper control is 40.59, lower 17.27, and then plotting the data points for the average. We go back up here, 33.67, 33.67. I think I have math wrong here. 26, 18, and 35 divided by 3 is, no, that's right, 26.33. However, oh, no, I do have it, 26.33. The third point, 29.67. There we go, I was looking at the wrong ones. 29.67, 21, and 34. 21 and 34. And again, we're just looking at the X chart. And again, it looks like we are falling within the upper and lower control limits. Generally about the same above and below, and we are going to say that the process is in control. So you could have, back in the Goodman example, you could have looked at just the R chart to start off with, and it looks to be in control. But you want to actually be looking at both the R chart and the X bar chart, because they show different, they pull out different information, and this is showing that we are becoming out of control in our process. So in summation, we need to have a target value that we're setting and looking at how our values fluctuate around that center line in both the R chart and the X bar chart. And this concludes the quality control lecture.